Now find the exact values of the trigonometric expressions given in part A through part D, and we are given that sine theta equals 2 over 5 and theta greater than 0 less than pi by 2. So basically theta lies in quadrant 1. So I'm going to construct a terminal arm in quadrant 1, and I basically construct a right triangle like this. So I put this theta here. Maybe I could mark this vertices as OAB. So we have this right triangle OAB. Now we are given that sine theta equals 2 over 5. So when we use the SOHCAHTOA, this 2 represents the opposite side and this 5 represents the hypotenuse. So which means I can mark this side length AB as 2. This is the opposite side to theta, and this side length or this hypotenuse OA is 5. Now we have to determine OB. We can do that using the Pythagorean theorem. That is, OB is basically equivalent to OA quantity square minus of AB quantity square under the root. So let's substitute OA. OA equals 5. Therefore, this becomes 5 square minus of AB is 2. So therefore, this becomes 5 minus 5 squared minus 2 squared. And this equals 25 minus 4, and this is equivalent to square root of 21. So basically we found the value of OB equals under the root of 21. And since we have found this the side OB, using now we can find the cos theta from this right triangle. So I represent cos theta equals according to SOHCAHTOA, cos theta is adjacent side. So the adjacent side to theta is square root of 21. So I put this under the root of 21 over hypotenuse, which is 5. So basically we found the trigonometric ratio cos theta equals square root of 21 over 5. Let's find the exact value of sine of 2 theta. First, I'm going to rewrite this using the double angle identity. So sine 2 theta equals, this is 2 sine theta times of cos theta. Now we know the value of sine theta, which is 2 over 5, and cos theta, and this is equal to under the root 21 over 5. We can substitute this and find the exact value. So therefore, this becomes 2 times of 2 over 5 multiplied with under the root of 21 over 5. So we multiply the numbers in the numerator, that is 2 times of 21 times of root 21. So therefore, this becomes 2 times 2 is 4, and then we have this root 21. So it is 4 times of root 21, and in the denominator we have 5 and 5. So when we multiply these two, we get 5 times 5 is 25. So basically, this is the exact value of sine of 2 theta. Let's do part B now. So we have to find the exact value of cos of 2 theta. Using the double angle identity, I can rewrite this as 2 times of cos square theta minus 1. And this equals 2 times of cos theta quantity square minus 1. So this can be written as we can plug in the value of cos theta, that is under the root 21 over 5. So therefore this becomes under the root 21 over 5 quantity square minus 1. Now when we square this under the root 21 over 5, this under the root 21, the square root will go off, and then 5 square is 25. So this becomes 21 over 25 minus 1. Now we can simplify this. This 2 times 21 is 42 over 25, and I put this negative 1 as 25 over 25. So therefore we can simplify the fraction, that is 42 minus 25 over 25. So this becomes 17 over 25. So this is the exact value of the trigonometric expression cos of 2 theta. In part C, we have sine theta over 2. So we can use the half angle identity. Sine theta over 2 is equivalent to 1 minus of cos theta over 2 under the root. And we will have plus or minus since theta lies in first quadrant, we utilize the positive quantity. So we have to substitute the value of cos theta. So therefore this becomes 1 minus of under the root 21 over 5 divided by 5 under the root. So let's simplify this. So therefore this becomes 5 minus of under the root 21 over 5, and then we have to divide by 2. So therefore this 5 and 2 will get multiplied, and this becomes divided by 10. So this is the exact value of sine of theta over 2. In part D, we have cos of theta over 2. Using the half angle identity, we can rewrite this as 1 plus cos theta over 2 under the root. So we have to plug in the value of cos theta. So let's do that. So therefore this becomes 1 plus under the root 21 over 5 over 2. We simplify this. So the numerator part will become 5 plus under the root 21 divided by 5 times of 2 is 10. So this is the exact value of cos theta by 2.